our influence on the atmosphere. So solar radiation not reflected by clouds passes through the atmosphere. So if it hits the clouds, it's going to be reflected back to space. If it doesn't hit clouds, it's going to pass through the atmosphere. And then this radiation is absorbed by Earth's surface. And then that's going to warm up the surface, and then that's released from Earth's surface as long wavelength radiation. In other words, it's released as infrared, which is the same thing as heat. This radiation is absorbed by atmospheric gases such as water vapor, methane, and carbon dioxide. And then some of this absorbed energy is then re-radiated back to Earth's surface because you're basically warming up these molecules, and then they will release that heat again, and that comes back to Earth's surface. And this basically results in the greenhouse effect. So in diagram form, it looks something like this. You have solar radiation coming in. If it hits clouds, well, it'll just hit the cloud and bounce back off into space. Okay. If it passes through the clouds, it's going to hit the surface, warm up the surface. Then you're going to have this longer wavelength radiation being emitted from the surface as heat. Gets absorbed by greenhouse gases in the atmosphere and then re-released back towards the surface. So solar radiation reaches Earth's surface where it is re-radiated as long wavelength radiation. And this radiation does not easily escape through the atmosphere and is mostly absorbed and re-released by atmospheric gases, such as methane, carbon dioxide, and water vapor. Now this process is called the greenhouse effect. Now, the greenhouse effect is the natural heating of Earth's surface caused by certain atmospheric gases called greenhouse gases. So this is a natural process. The greenhouse effect is not something that humans have created. In fact, without the greenhouse effect, Earth would be a lot colder than it is now. It'd actually be a big ice ball pretty much. But this does warm Earth's surface by more than 30 degrees Celsius and also helps maintain a consistent temperature. So without the greenhouse effect, when the sun set, the temperature would drop rapidly, like on the moon. On the moon, it goes from really hot when the sun's out to really cold when the sun sets. So without this, life as it currently exists on Earth would not be possible. Okay, so the greenhouse effect makes life as we know it possible. So changing the amount of atmospheric greenhouse gases such as carbon dioxide and methane changes global temperatures. This has kind of been shown through evidence now that this happens. Global warming is a rise in global temperatures due to increased greenhouse gases, particularly carbon dioxide, but also methane from like natural gas drilling and stuff. Now, more appropriately, this is called global climate change. Since increasing the average temperature changes long-term averages and variations around the world. It doesn't necessarily mean everywhere is getting hotter all the time, but it does mean that the climate is changing. Maybe it's rainy somewhere it used to be dry, or now it's dry somewhere it used to be rainy, etc. Now, greenhouse gases have been found to fluctuate over time throughout Earth's history. We get this information from ice cores. So we can measure this in ice cores, sediment cores like at the bottom of the ocean, and then isotopes in rocks. So there's different ways we've been able to determine what the composition of the atmosphere was in the past. And we've determined that these greenhouse gases do fluctuate. So there's a positive correlation between these gases and global temperatures. So increasing greenhouse gases in the atmosphere have led to increasing temperatures. And vice versa. So decreasing greenhouse gases are correlated with decreasing temperatures. Now, these changes typically take tens of thousands to millions of years to occur. So these changes typically don't happen very quickly, but the current changes have occurred in about 150 years. So the current changes we're dealing with have occurred over 150 years to 200 years, whereas typically these take tens of thousands to millions of years. Now, over this 150 years, the carbon dioxide concentrations have increased from 280 parts per million to over 400 parts per million in the atmosphere. It doesn't sound like much, but that is enough to cause significant changes in temperature. So some of the data for this. So what we have here is the gray line is showing our atmospheric carbon dioxide concentration in parts per million, and that's on this side, this axis over here. So 280 to about 420. And you kind of see from 1880 to 2020, this has just steadily increased up until really it's kind of a slow increase until you get about 1970, and it actually starts to increase a little quicker. Now, these bars, the blue bars and the red bars, are the difference from 20th century average temperatures. So what we've done is taken all the temperatures from the 20th century, so from 1900 to 2000, taken an average of that temperature, and that's what this line is here at 0. And then the blue years are years that were lower than that average, and then the red years were years that were above that average. So we see up until the 1930s, they were all below that average. And then from the 1930s to the 1970s or so, we have this sort of back and forth between there's some warmer years and cooler years and warmer years and cooler years. And then from about the mid-1970s on, all the years have been above this average. So you can kind of follow this as our change in temperature. But the big thing to note here is that these two follow each other. So as the CO2 concentration has increased, it pretty much follows the temperature differences. So as the CO2 level increases, it does follow these temperature changes. This is just kind of a global temperature trend to kind of show that this is not just from one person saying, or one group saying the temperature is warming up. This is actually 5 different organizations, either government agencies or universities or other independent researchers, are all showing this sort of basic trend. Some of the data is varied a little bit, sure, but the trend is the same for all of these. So the whole point of this graph is to kind of show it's not just one organization saying it's getting warmer. There are a bunch of organizations that are tracking temperature data and showing that there are increases. Now, global climate change. So global temperatures have shown an upward trend over the past 200 years. And the top 10 warmest years on record have all happened in the past 2 decades. So in the past 20 years, we have had the 10 warmest years on record. Now, a couple of examples. 2020 was the 2nd hottest year on record right now. And then 2022 is now the 4th hottest year on record. And then current computer models predict that the average temperature will continue to increase. And these models strongly depend on the net amount of human-generated greenhouse gases added to the atmosphere each year. Now, these models incorporate all those other natural causes and stuff that we've talked about as well, but also they add in the amount of human-generated greenhouse gases. And these models predict a continued increase in temperature. So consensus among scientists is one of those things that kind of gets thrown around sometimes, that scientists don't agree, etc. But scientists do agree this is happening and it is human related. But based on empirical evidence, i.e. real world evidence, so empirical evidence is real world evidence, from multiple sources, scientists have concluded that global warming is occurring and global climate change is a thing. Most, so 97% of active climate scientists agree that the warming trend is due to human activity, and that's data from NASA. More than 97% of published climate articles from 1991 through 2011 also support the idea that humans are causing the rise in global temperature. So there is this consensus from most scientists that the warming trend is caused by human activity. So an overwhelming majority of scientists from a variety of fields, including climatology, meteorology, geology, astronomy, and physics, have found the natural cycles alone cannot explain the current anomalous rise in global temperatures. So one thing you gotta be careful about is this word scientists here. You gotta look at the right scientists. You have to talk to people that are in that field or in a closely related field for their opinions on it. So the 10 hottest years on record. So this is kind of showing the 10 hottest years on record up to, this was published in January of 2022. So as of that point, the 10 hottest years on record, 2013, 2010, 2014, 2018, 2021, 2017, 2015. So you kind of get the idea here. If you kind of start, you got 2010, and then you got 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 goes in here now as well. I think it's the fourth one, so it'd be 1, 2, 3. So it'd be like right here between these. So 2022 would go right there.